I'm in SQL+, and to start off with, we want to do two things. First, you want to set your line size to a value so the output doesn't wrap. I usually find that a value of 120 works, so let's go ahead and do that. And the second thing you want to do is you want to enter the following command. Set Autotrace trace only. What this tells SQL+ to do is to go ahead and run the SQL statement, but just show the Autotrace output, and don't actually print the results of the SQL statement to the screen. Having done both of these, let's go ahead and enter in our SQL statement and see what we get. We see here that we get 3 items. The first 2 items are the execution plan and the predicate information. And this is much the same information as we saw before, it's just formatted a little bit differently. The third block of data that we get is this section down here, and this is giving us some of the overall query statistics. So one of the first things we see is our number of consistent gets, and these are our logical reads, and this is the same number as is shown before. We also see the number of physical reads Oracle has had to perform for this SQL statement, and we see that this value is 0, meaning that all the data Oracle needed was in the buffer pool. Oracle didn't actually have to go out and get any data from disk in this case. Typically though, you will see some physical reads, and the larger the numbers of logical and physical reads that have to be performed, the slower your SQL statement is going to run, so you'll want to investigate these if you have some high numbers in these 2 rows. Moving down, we see we have some information about the amount of network traffic this SQL statement generated. There were 1150 bytes that were sent back to the client by Oracle, and in this case there were 2 network round trips. So if you have a SQL statement that's returning a lot of data back to a client, you might want to take a look at this data, because obviously if a lot of data has to be sent over the network, resulting in a lot of network round trips, this is going to have an adverse impact on performance. Next, we have some information about the number of sorts that Oracle's performed. Oracle had to perform 2 sorts, and both of these were able to be performed in memory. If you see that Oracle had to go to disk to perform a sort, this is where you want to be concerned and investigate what is happening. What's going on is that Oracle had a data set that's so large in these cases that it can't be sorted in memory, so it has to go out to disk in order to perform the sort. Obviously, the performance of using a disk in a sort operation is going to be much slower than doing an in-memory sort. What you want to do is look at why Oracle has a data set that's so large that it can't be sorted in memory. If you can, trim this data set down to contain fewer rows so Oracle can perform the sort in memory. Finally, we have the number of rows processed, and in this case, this is the number of rows that the SQL statement returned. So you can see there's a wealth of information that Oracle makes available to us about what our SQL statement is doing. By looking at the cost of each step in an execution plan, the number of rows that are produced by each step, and the number of IOs that need to be performed, we can quickly tell which steps are driving the performance of our SQL statement, and when we do make changes to try to improve this performance, we have a lot of data which we can go to look at and judge how successful those changes were.